Welcome to the lecture. And last week we talked about how to solve first order uh, linear differential equation by using integrating factor. So let me recap what is first order linear ordinary differential equation. Like if you're given equation of fx y prime plus gx y equals hx with fx is not zero. This is called first order ordinary linear ordinary differential equation, right? So uh, the integrating factor was to solve this equation, and today we are going to deal with some specific types, some special type of first order linear ordinary equation. Uh, there's an equation whose form is like dx dy equals fx comma y. And among these kind of equations, there's special types of equation called separable equation, which belongs to this type. And this has the form of mx dx plus ny plus dy equals 0. This m is the function only in terms of x, not related to y. And on the other hand, this function n is written only in terms of y, and it's not related to x. So in this case, the special thing is that we can organize this equation in terms of uh, this form, like putting all the x-related term in one hand side and putting all y terms on the another side. So this looks very familiar because we can take integral sign, then it's like uh, the equality of two integrals. If we organize this term doing some calculations that you've learned in Calculus 1-1, you can have the form of solution. Like basically, you can have implicit solution. Like it's like something related to y, uh, like equation in terms of y equals equation in terms of x. So that means that you can get a solution that is not the form of y equals something related to x. But if you are fortunate, you can get uh, the solution of the y equals equation in terms of function in terms of x, let's say function, and also function. That is, we call it explicit solution, right? So that's the point of using solving the separable equation. And even though you get implicit solution, not the explicit solution, you can just guess the relationship between x and y. And these are really important information when you have to analyze the dynamics of this dynamical system. So let me give an example of this separable equation. Like let's say dx dy equals this form, and we can we know that the product of these two terms and product of these two terms are equivalent, right? It's from basic algebra you learned in elementary school. And this principle holds also in differential equation, which is very good news. This implies that x squared dx equals 1 minus y squared dy. Then you can put the integrals on both hand side, and let's say it as left hand side, and let's call it as right hand side. So the left hand side would be the integral of dx equals plus c1, and it's from basic calculus. And let's calculate the integral of the right hand side. It will be y minus y cubic, and the coefficient would be 1 over 3. So you know that the equality holds. This means this and this are equal, right? So let me organize that like y minus, sorry, I missed also constant, y cubic plus c2 equals x cubic plus c1 is right hand side, left hand side. They are equal. So we can put all the constant in right hand side for convenience, and it will be plus c. Just like we don't need to use two coefficient, two constants, because constant plus constant is constant, and constant minus constant is constant, which may make this equation simpler, right? So let me move on to another example. Uh, 2 y minus 1 and 3 x squared plus 4x plus 2 in the numerator, and it has the initial value of y0 equals minus 1, which means if x is 0, then y should be minus 1. So as we did in the previous example, like the product of these two terms equals to product of these two terms, right? So 2y minus 1 dy equals 3x squared plus 4x plus 2 dx, right? And let's put an integral on both hand side. And this would be uh, y minus 1 squared plus c1. And instead of like integrating in each term, I integrated this whole square term for convenience. And you may know the reason uh, as I proceed. And the integration of it would be x cubic plus 2x squared plus 2x plus c2, right? And we can organize them using this equality, like we can guess y minus 1 squared equals x cubic plus 2x squared plus 2x plus c2 minus c1. And these are constant, right? So x squared plus 2x plus some constant c. And we can take the square root, but we have to judge whether it will be plus sign or minus sign, right? Plus, minus. And we have to judge whether it's plus or minus. But the good news is that we have the initial value. So when we plug as 0 to the x and minus 1 to y, then we can get minus 2 equals plus minus 0. So it will be c, only c remains, right? So we can guess that, first of all, the minus should hold, and the c would be 2 to the power of 2, which is 4, right? So we can get y minus 1 equals minus x squared plus 2x, x cubic plus 2x squared plus 2x plus 4, and we can get the explicit solution of this equation like this form, right? So yeah, today we dealt with the separable equation and its solution, how to solve this equation. And next week, we are going to talk about some more properties of linear uh, equation, and we are going to deal with uh, the relationship between homogeneous equation and non-homogeneous equation. Okay, thank you, and see you next week.